Okay, so today we are starting matrices, and as we go through these, you're going to see some similarities to what we did yesterday. Okay, so 10.3 is matrices and systems of linear equations. And then I asked you to read through this, so I'm just going to go through it really quick. Basically, the matrices is used to organize pieces of information. So you had an example of a matrix with that chart. I'm just going to move this here. So if you have an augmented matrix, it's going to contain the same information as your system, but it's just in a simpler form. So really, if you were explaining how to take this from a linear system to an augmented matrix, what would be an easy way to say that to somebody? Yeah, you take the coefficients, right? And those are going to be organized in different columns. So everything in the first column is going to be the coefficient of what variable? X. Everything in the second one is going to be the coefficient of y, and then the third one is, in this case, is going to be your constant. So the last row is always going to be your constant row. Now, if you have an m by n matrix, there's going to be m rows, and there's going to be n columns. And then look at the way the entries are written. So this is A sub 1, 1. So it's not A sub 11, it's A sub 1, 1. The first one stands for the row, the second one stands for the column. So see how this is 1, 2? That means first row, second column. 2, 2 means second row, second column. Okay, so on and so forth. Do you guys have questions about that notation? You can, it says here that it's the ith row and the jth column because they'll call it A sub ij. So I know that might be a little bit hard to see on your sheet, so if you wanted to write it out so that you could see it better, that would definitely be something that you could do. Okay, and then here are just some examples. So there's a 2 by 3 matrix, so 2 rows, 3 columns, a 1 by 4, 1 row, 4 columns. And then again, I transferred this over so I don't think everything lined up. Okay, so if this is my linear system, this is going to be my augmented matrix. Now notice that this one is missing a variable, so if it's missing a variable, then a 0 is what is going to go in place here. Oh goodness. Sorry, I didn't mean it. Okay, so that's going to be your matrice. Okay, so your linear system, your augmented matrix that goes with it. So we have elementary row operations. These elementary row operations are basically the rules that we can use to put matrices in a certain form. So the first one is going to be, let's just use a normal pen, green, because green's my favorite color. So you can add a multiple of one row to another. Well, a multiple is just multiplying by a constant, which is what we're doing here. You just can't multiply by 0 because then that does change the value. Any of these operations don't change the value at all. And really, if you're adding a multiple of one row to another, that's just what that we did yesterday. Yeah, that's just elimination. Okay, instead of spending an hour writing that down, you know what I'm saying. Okay, so that's going to be elimination. And now you can also interchange two rows. So let's say you want to make row 2 into the row 3 position, you could just switch those. From yesterday, do you guys remember why that would be helpful? Yeah, to make the triangle type system. Alright, so we're going to use the following rotation to describe the elementary row operations. And there's going to be 2 different ways of writing your systems of the linear equations. I'm just going to give you some examples on this slide, and you guys can just write them underneath. Okay, so let's say you wanted to multiply row 1 by just going to put O for original. You could do 2 times row 2, and then let's say you wanted to add that to row 1, and then you would tell me what row you're going to substitute that for. And in this case, you could just put row 1. Okay, so this would mean multiply row 2 by 2 and add to row 1. And then that would be your new row 1. Yes.
So the O, is that O or 0?
That's O for original. Yeah, yes, O for original. So the original matrix and then to the new one. All right. Okay, so this is to solve the system of linear equations, and I asked you to read through this one because it's actually solved for you. I just wanted you to see it one time before you actually did it yourself. Yep. Yeah. What went wrong? Yeah.
Me?
Yeah.
Oh, I was gonna ask, why do they use 1? They don't really need to use 1. Because whenever they eliminate the variable, like they start off eliminating x and then y, and then they get it down to z, but whenever they eliminate x from 2 of the equations, but it should be also eliminated from the third, they just denote it with 1. Why do they do that instead of just putting a 0 there?
I'm confused. Oh, you mean with the first one here?
Yeah, because you put, you multiply equation 1 by -1 and then add it to equation 2, and then you multiply equation 1 by -3 and add it to equation 3. But, like, hypothetically, that would eliminate the x from equation 1, equation 2, and equation 3. But
Right.
they still leave it there and just denote it as 1.
Yeah, you wouldn't want all of them to cancel out. If you're looking at the next thing, just wait and I'll get your question when we get there, just so I can see what you're talking about. So your goal is to eliminate the x term from the second equation and the x and y terms from the third equation. Okay, so when you are writing your different terms, you're going to write them in the augmented matrix. Okay, and then so if this is your system, this is going to be your augmented matrix. Okay, so what we want to happen, and you can see it in this first column, is you want the coefficient here to be a 1. This is actually called a leading 1. So in order to do that, to get the leading 1, in this case it was already there, so you don't have to do any operation. After that, what you want to do is get the 2 zeros. So in this case, in order to get the zeros below, what happened is we took row 2 and we subtracted row 1, and then that was our new row 2. So I'm going to go over with you how that came to be. So if you do row 2 minus row 1, row 2 minus row 1, 1 minus 1 would be 0, so that's going to be our 0 here. Row 2 minus row 1, 2 minus negative 1 is 3. Negative 2 minus 3 is negative 5, and 10 minus 4 is going to be 6. Okay, so that was one step. And in this case, you could do 2 steps at the same time. So to get our 0 here, we did R3 minus 3 times R1. So if you do R3 minus, in this case it would be negative 3 times 1 or negative 3, you get 0. This would be negative 1 plus 3 because it's a negative times a negative. And then you get 2. And then for row 3, you'd have 5 minus 9, which would be negative 4. And then the last one would be 14 minus 12, which is how we get 2.
So to be able to leave the first equation as 1 in the x variable spot, then you have to make 2 figurative equations that can cancel out equation 2 and 3 for the x variable, and then you leave the equation 1 as it is.
Yeah, so you're going to leave equation 1 as it is.
Because it just changes the appearance of 2 and 3.
It is, and then eventually we're going to, I'm going to show you how to put it in what's called row echelon form.
Where you have the components and then 0.
Yeah, and one right here.
Yeah, why
Yeah.
multiply by 3?
That, because what you want to happen is you want these to be 0. So in order to get it to be a 0, you want to perform operations that will make that a 0.
Okay, so it can change.
Yeah, yep, exactly. So,
And you can also do that to row 2.
and yeah, and with your matrices, you might have something different than everybody else about how you got there. I'm going to show you some good strategies on how to get there. So like with this one, the next thing that you want to do is you would want to get, you really want to get what's called leading ones. So to do that, you can take row 3 and multiply by a half. So if you're looking at something and you want to make it a 1, but it's a 2, then you could multiply by 1/2 to make it a 1. If it's a 12, you could multiply by 1/12. Okay, and then this shouldn't say R. This should say. Just hold your question for a second. We'll get to the next one. Alright, I moved that. Okay, so this would just be your arrow. Okay, so with Gaussian elimination, what we're going to do is we're going to put matrices in row echelon form and reduce row echelon form. So reduce row echelon form and row echelon form you can call REF, that's just row echelon form, and then reduce row echelon form is RREF. Okay. So these are going to be your steps to put these in reduced row echelon form. Let me use my highlighter. So the matrix is in row echelon form if the first non-zero number in each row is 1, and that's called the leading entry. So you want that to be a 1. Then the leading entry in each row to the right of the leading entry is also going to be 1. Okay, so each leading entry is going to be a 1 and it has to be to the right. If you have a row of zeros, those are going to be at the bottom. And then the difference between that and reduced row echelon form is that every number above and below, each leading entry is going to be 0. Okay, so this is an example of a matrix that is not in row echelon form. So see how this is your first leading 1? This does not go to the right, so we can't have that. Okay? Oh my goodness. Okay, so we do not want that to go to the right there. I need to stay away from this magic marker. I'm sorry. Okay, so because that's not to the right, it's not in row echelon form. Let's take a look at one that is in row echelon form. So if it is in row echelon form, you can see here that all of the leading 1s shift to the right, and also notice what is underneath all of the leading 1s. Yeah, so underneath them is going to be zeros. That's also what you want, is you want zeros underneath the leading 1s. Now, it's reduced if you still have all these zeros, and then you still have the leading 1s, but then in addition, you're also going to have the zeros above the leading 1s. Okay, so see how the position here is all the same? The difference is you're just going to get zeros above. The benefit of having reduced row echelon form is you would be able to find all of the equations right away. And for row echelon form, you could use back substitution. So that's why we do want to put it in row echelon form. Yeah, Jen?
Why do we have a row of all zeros there?
Well, and this is just an example, but if you had a row of all zeros at the end, then the system would be dependent because you would get like 0 equals 0. And if you have 0 equals 0, it'll be dependent, but we're gonna talk about that later. Okay, so this is your systematic way to put a matrix in row echelon form. So you want to start by obtaining 1 in the left-hand corner. That's your first step. Okay? Then you're going to obtain zeros below that 1. So step 1, obtain the 1 in the top left-hand corner. Then you're going to obtain zeros below it. And then you're going to obtain a leading 1 in the next row and obtain zeros below that. Okay? And we'll go through that part together. So at each stage, you want to make sure that the leading entry is to the right of the 1 above it. And then you also just want to make sure you have your zeros underneath your leading 1. Okay? And then that will be row echelon form, and then you can use back substitution in order to solve. So in a nutshell, here are your 3 steps. Step 1, you're going to make the augmented matrix. Step 2, you're going to do row echelon form, and this is going to be the longest step. And then the last thing you're going to do is back substitution, is what we did yesterday. Okay, so you're going to solve the system. I actually already did step 1 for you. So step 1 is to put that in an augmented matrix, and I did that. And I'm sorry, there needs to be more space between these, but that didn't happen. Okay, so you're solving your system. This is your given system. I know on your paper it looks nicer. And then you are putting that into an augmented matrix. And again, the augmented matrix is just the coefficients. So all the coefficients of x are in column 1. For y it's column 2. For z it's column 3. And then our constant is the last column. Alright, so we need to get a 1. So the first thing we're going to do is we're just going to start with our matrix. And then you guys can just write this at the top of your page. Don't try to squeeze it into the little boxes. Okay, so just write this at the top of your page. So here's my augmented matrix. So 11, 7, negative 6. And then 22, 14, 1. And then the last row is 22, negative 10.
It's negative 11. Yeah, Miss, why do you make the funky numbers?
I didn't. These are actually, this one will actually work out nicely. So sometimes you will have to deal with fractions, but
Why aren't you
this
gonna
one you don't have.
multiply something by like 11 or something?
Okay, so the very first thing you want to do is you want to make this a 1. So to make that a 1, I can multiply by what?
11 over
1 over 11. Okay, so what we're going to do is we're going to multiply. Okay, we're going to multiply the first row by 1 over 11. And then this actually works out nicely because if you look at the very first one, see how 11 is going to go into all of them evenly? Okay, so now we're going to have 1, 2. What's negative 11 divided by 11? Negative 1. 22 divided by 11? 2. Okay, and then all we did is we did this with row 1. So row 2 and row 3 are going to stay the same. Okay, so your first step is to get your leading 1. Once you get your leading 1, you're going to get your zeros.
orange to like 7/11.
Yeah. Multiply that by the second row.
Oh,
Step.
oh,
Yeah.
and then you were
11.
thinking you could subtract that, but then that would be 0.
But you could
No,
still
11
do
over 7.
7/11.
Yeah, but if you did 7/11, you get 7 there.
No,
Yeah, then
11
divide
over
by
7
7.
to the second row, and then that
But
would
then
be
you could just
a
divide it
negative
by 7.
11 over 7 to the second row, and you get negative 11 over 11, and then it's going to cancel out. But it's not going to make 0, or else everything else would be 0. Because it follows the rules.
There, yeah, as long as it follows the rules, that's fine. Um, once we start to get more into your other steps here, you are gonna want to do it in a certain order because it will always work out that way. And if you don't, then the work that you've done when you add it to other rows is gonna be lost. Nice. Okay, so now that I have my zeros here, the next thing I want to do is I want to make this into a 1. So what can I multiply that by? 1 over 13. The easiest thing to do is to multiply it by that fraction.
Wait, is this the switch thing?
We already
Well, what
switched it.
numbers are these? Wait. Oh, so we're continuing on. Wait.
Okay, so now what we're gonna do, we already switched them, okay? Look, okay? Stay with me, please.
I'm doing my best. It's really hard.
No, I'm not just talking to you. Okay, so once you multiply by 1 over 13, this is nice because the first one is 0, so it's gonna stay 0. Then we'll have 1. 52 divided by 13 is an even number. What is it? 4. Negative 39 divided by 13 is also an even number. What is it? Negative 3. Okay? So, and then your third row is going to stay the same. So let's look at the progress that we made. Okay, so remember how we talked about we want a 1, a 0, and a 0. We had that. Now we have a 1 and a 0. So then the next thing we have to do is get a leading 1 in which row? Yeah, now we want to get a leading row in the third row. So we need that to be a 1. Okay, exactly. So then we're going to multiply that row by 1 over 12. So 1 over 12 times row 3. Okay, so this is going to stay the same. Shh. Okay, and then the bottom row I multiplied by 1/12. So this is nice because those are going to stay 0. 12 divided by 12 is 1. Negative 24 divided by 12 is negative 2. Now we have this in row echelon form. So I'm just going to write REF because it's in row echelon form. Once you have it in that form, what you can do is use back substitution. Okay, so I'm going to show you how to do that as well.
The invariant multiply, but then I can get 1 first. Or can
That's what you should do first.
Can I switch up negative 6 up there and switch
Yes.
that over?
Yeah.
And would you get the same answer?
Yes. Your same final answer would be the same. Yeah, so if you guys shush. If you wanted to do something else in order to get this to be a 1, you could. So like if you added, can you guys see if you added these two rows, row 2 and row 3, you would get a 1. So if you want, you could add row 2 and row 3, and then you could make that your row 1. It would just be, you'd have different numbers here. Your process would be a little bit different. Your answers are going to be the same. Okay? Yeah, Trent.
So for what you just said, let's say I did, for the very first step, I did row 2 plus row 3.
Yeah.
Could I substitute row 1 instead of that? I could not do that, right? I would have to
Substitute.
like,
You could make it row 1. You
and
could
get rid of all row 1.
and redo it, yeah, because 7 plus negative 6 would be 1. So your first row would be 1, 15, 63, and negative 61. And that would be fine.
My other question is, when we flip them,
Yeah.
if we wanted to like do two things together, let's say I said row, interchange row 2 with
The only difference now is you have to get zeros above and below. Okay, so you want zeros that are above and below it. So basically, you'll have a matrix that looks similar to this. So 0, 1, 0, and then 0, 0, 1, and then you'll have some number here, some number here, some number here. And that's going to be reduced row echelon form. The only difference between reduced row and row is the zeros on top. In just row echelon form, they don't have to be zero. They could just be any number. So you can see this is how it works for the 3x4 matrix. It has written out just exactly what I wrote out there. And we are going to use our matrix from example 1, and we're going to put it into reduced row echelon form. So let's take our final one that we had. So 1, 0, 0, and then 2, 1, 0, negative 1, 4, 1, 2, negative 3, negative 2. And then we're going to put that into reduced row echelon form. Okay, so remember, our goal is to make sure there are zeros above the 1. Just wait. Okay, so if we're going to make sure that there are zeros above the 1, that means we want to make this is 0, this is 0, and this is 0. Now, for these steps, you really do want to perform the operations as I'm showing you. Do you guys have any ideas on how you want to make that 0? Okay, so if you there are a couple different ways you can do it. You want to be careful because you still want this to be a 1, okay? So when you add the rows together, you want this to be a 1. In order to avoid not getting anything other than 1, always multiply by the row underneath it. So if you're trying to make row 1 into a 0, you want to use row 2. So I can multiply row 2 by what? Negative 2. So negative 2 times row 2, and then add it to row 1, and that can be my new row 1. And the reason why you want to do that is because if it's in row echelon form already, this is a 0. So when I add it to this one, 0 plus 1 is still going to be 1. Okay? So the only row I'm changing in this step is going to be row 1. So I'm just going to write all the other rows the same. Okay, so if we do negative 2 times row 2, this would be 0 plus 1, so that'll still be 1. This will be negative 2 plus 2, so that'll be 0. And then for the next one, negative 2 times row 2, so what's negative 2 times 4? Okay, and then we're going to add it to row 1, so negative 8 plus negative 1, negative 9. And then let's try the last one. So negative 3 times negative 2 is 6. 6 plus 2 is 8. Okay, so now I made that a 0. Now I want to make these zeros still. So let's start with row 2. With row 2, you can multiply row 3 by what? So again, remember that you always want to use the row underneath it. -4 plus 4, which is going to be 0. And then -4, this is the one where you're actually going to have to make sure you pay attention. So -4 times row 3, -4 times -2 is 8. 8 plus -3 is 5. Okay, so now I want this to be a 0. Do you guys think you could figure out the operation that you're going to do? Yeah.
So like at this point, wouldn't we have a c equals -2 and a y equals 5?
Yep, so now we're gonna get it for x.
But can't we just plug those in and we're good?
Yep, but you're putting it in reduced row echelon
That was
form.
my question, is like, why are you doing this when you know that it's just
Well,
like.
because it's asking you to put it in reduced row echelon.
I know, but you could just like write it right from the beginning, cause you already know what x, y, and
Well,
z.
yeah, because you already saw it.
I know, but like you could just write it.
Oh,
Yeah,
I
but
see
you're
what
gonna have to use your operations in order to do it. So you're gonna